So, hi guys, welcome back to the second part of this YouTube series that is Computer Fundamentals, which we have already started in the previous lecture. So, in the previous lecture, we did the first three components. If you remember, basically, we discussed about what is a CPU, what do you mean by a GPU, what is the difference between a CPU and a GPU, and also discussing about like what are the different parts in a computer system. Like we discussed about registers, cache memory, also discussed about uh like what is exactly a cache memory, what is exactly a register. So detailed things we have discussed over there. So today I'm planning to complete with you from 1.4 till 1.9 because we have to cover the topics in a short amount of time. There is a lot of things left. So I'm planning to finish off this part because this part is really easy. It's completely based on theory. If you are good with writing the key points, as I always said, you're gonna get marks for it. And if I turn over here, so this is my handwritten notes. I mean, not handwritten notes, basically typed notes. You will get this in the description box. Check it out. Detailed notes from 1.4 till 1.9 is provided in the description box. Also, 1.1 to 1.3 is provided in the previous video. But over there, we have not provided a detailed notes. We have provided you like a summary type, what exactly you need to study. So we're gonna provide you the detailed notes over there also. So, yep, let's start with the class. Okay, so the good thing about this is I provided you the content, so you don't have to hover over to which page I have to go and all. So let's say if you want to go for pipeline, you want to learn pipelining, so you don't have to go in this and type. You can just click on this box and it will be automatically hovered over to pipelining. Okay, so yep. Okay, let's start. So our topic of understanding is different types of memories. Okay, so you know already what are the two basic memory types we have in a computer system, that is ROM and RAM. ROM stands for read only memory, RAM stands for random access memory. So let's move into the PDF. Yeah, there you go. So RAM, as I already said, RAM means what? Random access memory. Random access memory. Okay. And what is the random access memory? This is what you have to remember. So I have provided it in the purpose box. The temporary storage for actively running programs and data. What do you mean by this? Let's say you open YouTube, you browse through Edu Academy, you look for some videos, and then you decide, okay, that is enough for today. I'll just like shut down my computer and go. So when you shut down your computer, whatever you have watched in Edu Academy, the data which was stored in the RAM is lost. That doesn't mean that you can't get it back. When you open your computer once again and when you log into your YouTube and then search for Edu Academy, you can get back whatever content you, let's say you watch the video till 4 minutes, 10 seconds. You can actually get your video till there and you can continue from the next. But it not will it there will be no record of it. RAM means what? Once you switch off the computer, it's done. All right. So what are the key characteristics? So there are four key characteristics you have to learn. The first is volatile. What does volatile mean? As I said you, it loses all data when the power is turned off. Then fast access, that means what? It provides you quick read and write operations. The next you have is working memory. What does working memory mean? That basically, let's say I use Windows operating system. So this provides me an operating system where I can use my applications, data, whatever I'm doing. Let's say I'm teaching you guys. So I am opening my PDF reader from Adobe. So who is helping me to provide these applications? Obviously the RAM, because the RAM is the one who's storing currently stored data. So yeah, next one you have is direct CPU access. What does this mean? CPU can directly access instructions and data stored in RAM. That means what? Let's say I am doing something on a calculator and it's stored in a tab. So I can just switch back to the tab and do the calculation. So who is helping me to make sure that I can carry out these instructions and store it effectively there? My CPU. Not CPU, my bad. That's RAM. There is random access memory. So what it is used for? Common uses. So there are five uses I provided you here. That is running applications and processes simultaneously, storing variables and data structures, holding the operating system while the computer is powered on. I mean, which is happening to me. I have switched on my computer. I am in my operating system of Windows and I'm teaching you guys. Then temporary data storage during file editing and manipulation. buffering data between CPU and storage devices. Now we're gonna quickly discuss about ROM. ROM means what? Read-only memory. So whatever you learned in RAM, that means what? You can just temporarily store data for actively running processes and all. ROM is different. ROM says, hey, I gonna store essential instructions, important data, everything into me. But there's a problem. Nothing comes for free or without any purpose. Everyone has a purpose. So let's discuss the characteristics of ROM first. So it retains data even when the power is turned off. So obviously it saves your data. So even if your power is turned off, you turn it back, you can still look into your documents for the saved data. Next is read only. This is the biggest problem. It's highlighted here. Read only. That means what? It cannot be easily modified during normal operation. If you are doing an operation, you can edit the file. Not possible at all. Okay. Next is what? Boot instructions. It contains BIOS, firmware necessary for sorry. Yeah. So next we have is boot instructions. So it contains BIOS or UEFI firmware necessary for startup. What is BIOS? When you turn on your computer, you get some boot instructions which you have to follow. I mean, the computer has to undergo in order to make sure that your computer can start. So this is what we call BIOS. Okay. Next is factory program, written during manufacturing processes. Factory programs like creating a web app, modifying a web app, pushing some data into GitHub, all these cases. So, what is the common uses? Storing boot up instructions, firmware for embedded system, critical system initializer code, and bootloader program. Bootloader is what? Basically, what you see in the booting screen. If you want to learn about this in detail, we can discuss that in some other topic. That how you can see your boot up screen and what changes you can do to manipulate the working of it. Okay, so this is what ROM is essential for. All right. Okay. Next. Yes, our very famous cache memory. Already we have discussed about cache memory, but let's discuss in detail. So, ultra fast storage designed to reduce CPU RAM latency, as I told you. Frequently stored data. You want to go to YouTube, you don't have to worry about it. I have already stored it in cache. So it will make sure that it will reduce the CPU RAM latency. Latency means what? The small amount of time between the two. So characteristic, extremely fast. Faster than RAM, but significantly smaller in size. Yes, it's smaller in size, but it's way lot faster. Now there are some few hierarchical levels. You don't have to learn it in your. I mean, we can discuss about it later on. But in your exam, you don't have to learn about it in detail. So L1 means what? It's the smallest, but it's the fastest. L2 means what? It's medium level. L3 is the rarest of all. That means is largest, but the problem is the slowest also. Next is what stores frequently used data, which we have discussed, and this is the most important one. If you write your answer for this question, make sure this part is there. Use prediction algorithms to cache likely needed instructions. Next is located on CPU, physically integrated with or very close to processor cores, volatile data loss when power is off. That's it. That's what we call cache memory. Yeah, in cache memory also, once you switch off your computer, nothing is there. It's gone. So use cases, storing recently accessed instructions and data, holding frequently used variables, reducing CPU wait time. Wait time means what? As I told you, you don't have to wait for bringing the application from one part of the CPU to another because it's already stored in cache. Then improving overall system performance and throughput. Throughput means what? Efficiency basically. Okay. Now there is some example tip given here. You can read it where I'll provide the PDF in the description box. Okay. Let's move on. Yes. Here comes the most important aspect. Fetch, decode, and execute cycle. What exactly is this? So think it like this. You have to perform a task, right? So what is your important aspect? Fetch the data. Whatever you want to do, just gather all the information. That means fetching the data. After you fetch the data, what is the next task? Decode the data. What do you mean by decode? If you have alphanumeric characters or a very encrypted text, just decode it out. Decode it and try to figure out what the exact text that was given to me. And the third step is execute. After you have decoded it, just execute it normally how you would have done. All right. This is what we call the fetch, decode, execute cycle. So I have provided you the notes. Let's read it. Fetch. Program counter. Already we have discussed about program counter. What does it do? The program counter contains the memory address of the next instruction. The address is copied from the program counter to the memory address register, that is MAR. This we have also discussed. CPU retrieves the instructions from memory at the address. The instruction is loaded into the IR, that is the instruction register. Program counter is incremented to point to the next instruction. Then what are the key components? I provided you all the key components which we have discussed last video also. If you want to read it, the PDF will be provided. You can just read it and you will be done. Let's discuss about decode. Decode does what? The control unit examines the instructions in the IR. The instruction is split into opcode and operand. This is important. This is the main important line you have to write. Instruction is split into opcode and operand. Opcode means what? The operation which you want to perform. Operand means the data set which you need to work on. Control unit determines what operation needs to be performed, because as I told you, control unit is the one taking all the important decisions. Necessary circuits and registers are prepared for execution. Control unit sends signals to appropriate components. For example, I've given you, if you want to add up R1 and R2, so what is the opcode you add? Because what is your task? You want to add something. And what my opcode is R1 and R2, because these are the ones that will be basically added on. Okay. Next, the last one, execute. The instruction is carried out by the appropriate component. Arithmetic, as I told you, we discussed about ALU. ALU means what? It carries out arithmetic operations. Data movement, data transfer between registers of memory. Control operations, change to program counter for jumps and branches. So if you are currently in this position, you want to go to a particular position. So what you're gonna do? You're gonna jump from this place to this place. So who will make sure that it analyzes or controls everything? The execute stage. Okay, clear? Yeah. Okay. I provided some basic mathematical operations which you have to learn. Yep, which will be there for the exam. Like I'm just highlighting you once here. Yeah, there you can read from the PDF. Now let's discuss the next key component, that is the clock speed and the clock time. Okay, so what is the clock system clock? So the first decode execute cycle is synchronized with the system clock. Okay, understand it like this. I have given you a task. Hey user, you are supposed to do this. You have been given A, B, C, D instructions. You have to complete this within this time. You say, okay. You say, hey sir, I completed in 2 days. So that is what you completed in 2 days. That's the duration. And how much work did you do? You tell me that. After then, what I do, I figure out my speed. So I figure out that okay, you completed it in 2 days. This is the amount of work you did. So if I divide with the amount of work and time, I get what? My speed of completing my work. So clock speed is also the same. The time taken to complete one cycle of instruction in a computer. So it's measured in hertz, as I have mentioned here. Okay, typically gigahertz, billions of cycles per second. Example, a 3 gigahertz processor completes 3 billion cycles per second. Higher clock speed generally means for faster processing. Obviously, higher clock speed means more processing, more units will be processed. Okay, pipeline. Okay, there's comes the most interesting one. So before looking at the PDF, just think about this. You and your friend decide, ki, okay, today we're gonna build our own gaming console. I mean, not console, basically a own gaming setup. So you say, okay, let's build it. So you tell your friend, you build for the first 15 days. After the first 15 days, I will build. How much time will you take to finish it? 30 days. Okay. But what if I say you, hey, you build it for 15 days. I will also build it in 15 days and we'll both start together. So what is the completed time you'll get? 15 days. So pipelining is exactly that. If you have some processes, our task is to make sure that we can complete the processes in a less amount of time, basically efficiently. We don't have to give extra time to each of them. That means what? You have to make sure instructions are processed simultaneously, not one by one, all at a glance. And the definition also says the same. Technique that allows multiple instructions to be processed simultaneously at different stages of the fetch decode execute cycle, improving the CPU throughput and efficiency. So how does the pipelining work? I have given you a typical diagram. This diagram is very, very essential if you want to get marks. I have provided you. So you have an instruction one, you are doing fetch in clock one, clock two, you're decoding, clock three, executing. And if you see instruction two, I am doing my fetch from where? clock 2 is being decoded. And instruction I'm doing my fetch where clock 3 is executed and instruction 3 is executed and instruction 2 is decoded. So what is the purpose? First purpose, increase throughput, more instructions completed per unit time, better resource utilization, you utilize your resources much better, higher performance, and energy efficient. Okay. But there's some problems with pipelines. First problem is what? Most important one, data hazards. What do you mean by data hazard? So think it like this. Let's read the definition. Occurs when an instruction depends on the result of a previous instruction still in the pipeline. Instruction 2 needs the result from instruction 2 before it can execute. Okay. Some instruction 2, you want instruction 1. I ask you, hey, did you finish your task? But let's say you reply, no, I didn't. How can I go? I can't go because I am dependent on you. You have to finish your task, then only I can start my task. So this is what we call data hazards. There is a problem. Control hazards occurs with branch or jump instructions that change the program counter. CPU may fetch wrong instruction if the branch is taken. And what's the solution? Branch prediction algorithm. So you want to branch or jump from this place to this place. What will happen? There will be a big problem. If you are currently in one instruction and you are targeting that to be completed in some amount of time, but let's say you jump from this instruction to another instruction, what will happen? The time will increase. So pipelining concept is not applied here. So how you can rectify this? Branch predicting algorithms. That says structural hazards. What do you mean by structural hazards? Structural hazards means what? Basically, it occurs when hardware resources are insufficient for all pipeline stages. So what is the example? Multiple instructions need the same hardware components simultaneously, duplicate hardware resources, or pipelining stalling. That means what? You build something, you don't have the necessary hardware to complete it. Not possible. You can't achieve pipelining. Basically, this is what is being said here. Next is just multi-core architecture and pipelining. Very, very important. I highlighting the heading. Okay. What is a multi-core processor? A single CPU chip containing two or more independent processing cores, each capable of executing instructions simultaneously. That means what? I have a CPU chip. I have 4 or 5 cores working together at the same time. That means what? Each is capable of executing separate instructions. So what is the purpose? I get parallel processing. That means multi cores execute different instructions simultaneously. Each core has a pipeline. Each core implements its own pipelining. What is the next thing we can benefit from here? Task distribution. Operating system assigns tasks to different cores. Then is what shared resources. Cores may share L3 cache. L3 cache. You can turn your page and read it. We have provided you over L3 cache. So cores may share L3 cache and memory access. What are the advantages? Let's discuss about it. The first advantage is parallel processing it at much smoother to run multiple programs. Multitasking basically you will achieve from here. You have to give a very low power consumption. Why? Because it's more efficient. You are making sure all the tasks are done at the same moment of time. Performance is improved, the software can be optimized, and the best thing is synchronized. Everything is going in a synchronized. It's not like I'm going first, you're going 2 seconds later. No, we are all synchronized. You can read the example from here. Now we have the next part, that is the internal and external types of memory storage. So what's the secondary storage? Let's discuss that. We have already discussed what is the primary storage versus RAM and ROM. What is the secondary storage? Non-volatile long-term storage used to permanently store data and programs when not in active use. Unlike primary memory RAM, it retains data even when the power is, as I told you, if the power is switched off, I can't retain my data. But secondary storage or ROM says, hey, hold on, I can hold your data. Okay, but I told you it's read only. You can't alter it. Next, internal secondary storage. Let's discuss all of them. Let's discuss the first one, HDD. That is what we call the hard disk drive. So how does it work? This very rarely comes in exams. Not very important part, but if you still want to read, I provided you the notes. So uses magnetic platers that spin at high speeds. Reader write head moves across platters to access data. Data stored magnetically in circular tracks and sectors. Okay. Characteristics is what? Capacity, very large capacity. But the problem is the speed is slow, unfortunately, much slower than the SSD. Cost is what? Inexpensive. Inexpensive, but not very costly. Decent. Durability. Vulnerable to physical shock and damage. Any physical shock, any physical damage, there can be high chance that the device will be shut off. Okay. And what do you mean by noise? Audible spinning and clicking sounds, like a lot of clicking sounds, a lot of pointing sounds, which you don't want exactly to happen inside a memory. Okay. Now let's discuss about the other types of external hard drive. USB. We have all heard about pen drives, right? So what is a pen drive, or mean a USB? A small portable flash memory device plugged directly into the USB port. Capacity 8 GB to 2 terabytes. Speed, it varies. It's not like every pen drive or this will have the same speed. No, it will vary. What is the durability? It's pocket size. You can carry it literally anywhere. You don't have to worry about it. And then we have is optical discs. Optical discs were our very famous CD and DVD. Okay. So data encoded as bits and lands on the surface. Laser reads reflections to retrieve data. This is a very important point. I'll just highlight this for you guys. Okay. You have been given the capacity on. You don't exactly capacity doesn't come, but if it comes, then you can just memorize this one. Speed is what? Slower compared to HDDs and SSDs. Okay. What is the use case? Software distribution, media content, and long-term archival. Next, memory card, SD cards, micro SD cards. What are they doing? They are very small storage devices used for gaming, phones, camera. You can store heavy data, but a bit amount of data you can store. So, what are the use cases? Is an expandable storage for mobile devices, digital camera, video storage, data transfer from portable devices. Yep, you can transfer your data from literally any device. You can carry it anywhere. This is what we call memory card, SD or micro SD. Okay, so till now, whatever we discussed, did you guys get it? I hope it's fine. So, if I turn here, so what we have discussed about the fetch, decode, execute. We have also discussed about pipelining, and we also discussed about the internal and external concepts of the secondary storage. So we are just left with two things: compression and cloud implementation. As I said, so let's keep it till this. In the next video, we're gonna try to finish up this portion, that is 1.8 compression and cloud implementation, and then we can start with the next part. So I'll just show you the next part from here. The next part is data representation and computer logic, basically Boolean logic, which we need our whiteboard. Here we need our whiteboard to explain you properly how is a Boolean logic working, what is the K-map, what are the different types of Boolean algebra you have to remember. It's very easy, but a very important portion also. So, yep, let's keep it in this. We'll see you soon in the next video. If you like this video and if you think this video has really helped you out, make sure to like and comment, subscribe, and I'll provide you the link of this PDF in the description box. See you in the next class with the last two portions of A1.1, that is computer hardware and operation. Till then, take care. Have a great day. Bye.